Welcome back to my channel, dear student. I am Mahendra Singh. Today I am going to cover the topic joining method. What are the joining method? Welding, brazing, and soldering. Welding process like fusion welding, electric arc welding, gas welding, resistance welding, TIG, MIG, submerged arc welding, friction welding, newer welding method. These are the things which I am going to cover today. This is joining process. In joining process, what happen? Two or more metals are joined to each other by using heat or pressure, with or without using heat and pressure. The joint are may be permanent like welding or may be temporary like riveting, brazing and soldering. Joining process are screw fastening, welding, riveting, brazing and soldering. Here in the figure you can see here two pieces are joined by using the arc. This one is a electronic industry in which different semiconductors are joined on the printed circuit board. This is a soldering process. Here welding is done by joining a hollow pipes into on another pipes. This is a structure which is joined by using a rivet. This is a bridge. So this is next classification of welding process. What are the classification? Oxy fuel gas welding. In gas welding, what happen? We use acetylene and oxygen. Acetylene is in one cylinder and oxygen in another cylinder. Both gases flow at a high pressure by using nozzle, and after mixing combustion took place. uh, Due to combustion heat generated, and these heat is utilized for joining the two pieces. This is known as gas welding. In arc welding, what will happen? Arc is generated between two pole. Arc is generated between the cathode and anode. One uh, one piece will be anode and one piece will be cathode, and arc is generated between these two pieces. The types of arc welding: shielded metal arc welding, which is also known as SMAW in short form; gas metal arc welding, GMAW; pulse arc, short circuit arc, electroglass spray transfer, gas tungsten arc welding, flux core arc welding, submerged arc welding, plasma arc welding, stud welding. Then after arc welding, next is the resistance welding. Resistance spot, resistance seam, resistance projection welding, solid state welding. Our workpiece will be in solid state. Forge welding, cold welding, friction welding, ultrasonic welding, explosion welding, roll welding. Unique process: thermite welding, laser beam welding, electro slag welding, flash welding, induction welding, electron beam welding. Arc welding: this is the basic configuration of arc welding. This is the electrode, which is a consumable or non-consumable. If it is a consumable electrode, then it is a MIG welding. If it is a non-consumable, then it is a TIG welding. Then electrode is connected by the DC power source, and workpiece is also connected. Arc welding types: submerged arc, gas metal arc, shielded metal arc welding. In these three welding arc welding process, consumable electrode is used. In tungsten inert gas welding process, non-consumable electrode is used. Here in the workpiece, this is the clamp. This in welding machine, what will happen? In welding machine, voltage will be around 50 to 60, 70 volt, and DC current will be supply. Here rectifier is attached. One one wire will be connected to the workpiece and one will be connected to the electrode. Filler metal sometime will be provided. This is one is a solidified belt metal. This is a arc. This is the direction of travel. Arc shielding in arc welding process accomplished by covering. Why shielding is required? Because we know that in atmosphere lots of oxygen gases are present. So during building, what will happen? These oxygen will be entrapped in the workpiece. So for avoiding the oxygen entrapment, the shielding is provided. Shielding is provided by covering the electrode tip arc molten belt pool with a blanket of gas or flux. By providing the blanket of gas or flux on the welded region, we can provide shielding. Common shielding gas are argon and helium. In the welding of ferrous metal with certain arc welding process, oxygen and carbon dioxide are also used, usually in combination with argon and helium to produce an oxidizing atmosphere or to control weld shape. For controlling the weld shape, sometimes oxygen and carbon dioxide are also used. Flux. Flux is usually formulated to serve several functions: to remove, prevent oxide, provide a protective atmosphere, stabilize the arc, reduce spattering. These are the functions of flux. Flux delivery technique: pouring granular flux onto the bed using a stick electrode coated with flux material in which the coating melts during welding. Using tubular electrode in which flux is contained in the core and released as the electrode is consumed. So these are the three techniques of flux delivery. Next, arc welding consumable electrode. Consumable electrode is used in the rod or wire form. Welding rod 225 to 450 mm long and diameter is less than 10 mm. Welding rod to be changed periodically, reducing arc time of welder. Consumable weld wire. This is the welding rod and this is the wire. Continuously fed into the bed pull from a spool, avoiding the frequent interruption. Made of non-consumable electrode. Made of tungsten, which resist melting by the arc. Slow depletion, analogous to bearing of a cutting tool in a machining. Here very slow depletion. This is same like the beer occurring during the cutting tool in the lathe machine, milling machine, machining process. Filler metal must be supplied by means of a separate wire that is fed into the weld pool. This is a shielded metal arc welding. It is normally used during the manual welding process. Here electrode in the form of rod is used in on electrode coating will happen. Shielding gas from electrode coating. This one is the base metal, this one is the weld metal, this one is the solidified slag. Arc is generated between the electrode and workpiece. Shielded metal arc welding characteristics. Consumable electrode consisting of a filler metal rod coated with chemical that provide flux and shielding. Current typically used in shielded metal arc welding range between 30 and 300 ampere at voltage from 15 to 45 volt. If we want high speed, then we can increase the volt up to 60-75. Usually performed manually. Most common building 50% of industrial building uses shielded metal arc welding. Shielded metal arc welding electrode coating function. produces gases to shield build from air, adds alloying element deoxidation, produces slag to protect and support weld, control cooling rate, stabilizes arc. Electrode coating in shielded metal arc welding constituent. Shielding gas generator. Shielding gas is generated by either the decomposition or dissociation of coating. Three types: cellulosic, limestone, rutile. Cellulosic coating generates hydrogen, carbon monoxide, water, and carbon dioxide. Limestone generate carbon dioxide and calcium oxide slag. Rutile titanium dioxide up to 40%. Easy to ignite, gives slag detachability, fine bed appearance, generates oxygen and hydrogen by hydrolysis. Slag former, silicon oxide, magnesium dioxide, iron oxide, and alumina. Arc stabilizer, sodium bioxide, calcium oxide, magnesium oxide, titanium dioxide. Deoxidizer, graphite, aluminum, wood floor, binder, sodium silicate, alloying element, vanadium, cobalt, molybdenum, nickel, magnesium, tungsten. Shielded metal arc welding advantages and application. It is preferred over oxy-fuel welding for thicker section above 5 mm because of its high power density. The equipment is portable and low cost, making shielded metal arc welding highly versatile and most widely used arc welding process. Base metal include steel, stainless steel, cast iron, and certain non-ferrous can be welded. Disadvantage: electrode length varies during the operation. Length affect the resistance heating of the electrode. Current level to be maintained within a safe range, otherwise the coating will overheat and melt prematurely when starting a new building stick. Use of the consumable strode must periodically be changed, reduces the arc time, offer limited shielding protection compared to inert gas shielding process. Some of the other arc welding process can overcome the limitation of welding stick length in shielded metal arc welding by using a continuously fed wire electrode. There are some demerits of using electrode in the rod form. Consumable rod, which reduces the arc time. Lots of then by using continuously fed wire electrode, these the limitation can be overcome. This is gas metal arc welding. Here wire in the wire form electrode is used. Current conductor, treble, solidified belt metal, shielding gas, arc, nozzle, base metal, molten belt metal. Gas metal arc welding features: consumable wire electrode is fed continuously and automatically from a spool through the welding gun. Inert shielding gas protect the arc and the molten or hot cooling belt metal from air. Also provides desired arc characteristic through its effect on ionization. No electrode coating, no flux or additional filler. Direct current reverse polarity, high deposition rate is required. So electrode will be positive and workpiece will be negative. Flux cord arc welding. Flux cord electrode, consumable wire electrode, with or without shielding gas, core content, alloying element, shielding gas generator, flux. Submerge arc welding process. The blanket or granular flux submerge the welding operation, prevent spark, spatter, and radiation. In submerged arc welding, what will be happen? Arc will be submerged inside the granular flux. Flux will be supplied from the hopper. Vacuum system for recovery of granular flux. This is the vacuum system for recovery of granular flux. Submerged arc welding continuously consumable bare wire electrode arc shielding provided by a cover of granular flux. Granular flux is introduced into the joint slightly ahead of the weld arc by gravity from a hopper. Unfused flux remaining after welding can recover and reuse. Efficiency of energy transfer from the electrode to workpiece is very high. Welding is restricted to flat and horizontal position. We cannot do the welding on vertical position. Gas tungsten arc welding. Here tungsten electrode is used. Non-consumable tungsten electrode, inert gas for arc shielding, with or without filler rod, aluminum and stainless steel, high quality weld, no weld spatter because no filler metal, little or no post weld cleaning because no flux is used. Here no cleaning is required because here we are not going to use the flux. Inert gas is used for arc shielding. This is a plasma arc welding. An arc welding process that produces coalescence of metal by heating them with a constricted arc between an electrode and workpiece or between the electrode and the water-cooled constricting nozzle. Plasma, a gaseous mixture of positive ions, electrons, and neutral gas molecules. Due to the constricted nozzle, more heat is generated. Filler metal may or may not be added. Types of plasma arc welding: transferred arc and non-transferred arc. I am not going to much detail in plasma arc, transferred arc and non-transferred arc. Next, I am going to cover the resistance welding process. Here is a table form on the arc welding type summary. Shielded metal arc, electrode type consumable rod, electrode coating yes, filler rod not provided, shielding gas provided by electrode coating, flux provided by electrode coating, manual welding. So that's all about shielded metal arc welding. Gas metal arc welding, consumable wire, electrode coating not, filler rod not provided, shielding gas yes, automated welding, flux cored arc welding, consumable wire electrode coating nil, filler rod not provided, shielding gas with or without flux provided by electrode core. From the electrode core, flux will be provided. Manual and automated. Submerged arc welding, consumable wire electrode, flux, granular flux, manual automated, gas tungsten arc welding, non-consumable, automated welding. Welding process: resistance welding, generate heat through the resistance to the flow of electric current in parts being welded. The parts are usually an integral part of the electrical circuit. Contact resistance: heat the area locally by I square R melting formation of a nugget. Contact resistance must be higher at the point to be welded than anywhere else. Resistance welding: force. Pairs of water-cooled copper electrode apply pressure to reduce the contact resistance at the electrode to workpiece interface. Contain the molten metal in the nugget to literally force the weld surface together in the vicinity of the weld. The principal process variable: welding current several thousand to 10 of thousand of ampere, welding time of the order of second, electrode force and electrode shape, DC power provided from either single phase or three phase AC line, 440 to 450 volt using a step down transformer, Usually used to join overlapping sheet or plate as lap joint, which may have different thickness. Resistance spot welding, resistance seam welding, projection welding, flush welding, offset welding, precision welding. Spot welding, here in figure you can see series of discrete nugget produced by resistance heating. Nugget welds are usually produced directly under the electrode, not necessarily if there is another more favorable path for the current. Series resistance stop welding, resistance seam welding, conventional resistance seam welding in which overlapping spots are produced, roll spot welding, continuous resistance seam, electrode wheel, projection welding. Projection or dimple in overlapping joint element concentrate the current during building, focusing the weld energy and helping to locate the weld more precisely. Contact point determined by the design of the part to be joined may consist of projection, embossment, or localized intersection of the part. Flash building, normally used for butt joint, the two surfaces to be joined are brought into near contact. Electric current is applied, heat the surface to the melting point. The surfaces are forced together to form the belt. Upset welding. Upset welding is similar to flash welding. Heating in upset welding is accomplished entirely by electrical resistance at the contacting surface. No arcing occur, not a fusion welding process. Application of ultra upset welding and joining in soft wire, pipes, tube, etc. Finished upset weld. Offsetting force is applied. Solid state welding is a welding process in which two workpieces are joined under a pressure, providing an intimate contact between them and at a temperature essentially below the melting point of the parent material. Weld bonding is free from microstructure defect. Mechanical property of the belt are similar to those of the parent metal. No consumable material, filler material, fluxes, shielding gases are required. Dissimilar metals may be joined. Types of solid state welding: forge welding, cold welding, friction welding, explosive welding, diffusion welding, ultrasonic welding. Forge welding is a solid-state welding process in which low-carbon steel parts are heated to about 1000 degrees Celsius and then forged. Forge welding is used in general blacksmith shops and for manufacturing metal art pieces and welded tube. Advantage of forge welding: good quality welding is obtained. Parts of intricate shape can be welded easily. No filler material is required. Disadvantage of forge welding: only low carbon steel may be welded. High level of operating skill is required. Slow welding process: weld may be contaminated by the coke used in heating furnace. Cold welding is a solid state welding process in which two workpieces are joined together at room temperature and under a pressure, causing a substantial deformation of the welded parts and providing an intimate contact between the welded surface. As a result of the deformation, the oxide film covering the welded part breaks up and clean metal surface reveal. Intimate contact between these pure surfaces provide a strong and defectless bonding. Material used in cold welding: aluminum alloy, copper alloy, low carbon steel, nickel alloy, and other ductile metal may be welded by cold welding. Friction welding is a solid state welding process in which two similar parts are brought in contact by a friction pressure. When one of them rotates, friction between the parts results in heating therein. Force pressure is then applied to the pieces, providing formation of the joint. Material that can be welded in friction welding: carbon steel, alloy steel, tool and die, stainless steel, aluminum alloy, copper alloy, magnesium alloy, nickel alloy, titanium alloy can be joined by friction welding. Explosive welding is a solid-state welding process in which welded parts are metallurgical bonded as a result of oblique impact pressure exerted on them by a controlled detonation of an explosive charge. explosion, buffer plate, fire plate, stand up, distant base plate. Here on the above the flare plate, uh, buffer plate, uh, on the buffer plate explosion happen, and due to explosion the flare plate strikes on the base plate, and adhesion building between the two pieces can be, it is used for joining the two large pieces. Copper to steel, nickel to steel, aluminum to steel, tungsten to steel, titanium to steel, copper to aluminum. Different material can be joined by explosive welding. Large surfaces may be welded. Low cost and simple process. Surface preparation is not required. Brittle material, low ductility and low impact cannot be processed. Thickness of flare plate is limited. Safety and security aspect of storage and using explosive. These are the disadvantages. Ultrasonic welding is a solid-state welding process in which two workpieces are bonded as a result of a pressure exerted to the welded part combined with the application of high-frequency acoustic vibration. Ultrasonic vibration causes friction between the parts, which result in closer contact between the two surfaces with simultaneous local heating of contact area. Interatomic bond formed under this condition provides a strong joint. Dissimilar metal can be joined, very low deformation of workpiece surface, high quality weld is obtained. The process may be integrated into automated production line, moderate operator skill enough. Workpiece may bond to the anvil. This is the disadvantage. Only small and thin part can be welded. Other building process, electron beam building process, laser beam building process, electroslag building process, thermite building process. Electron beam fusion building process in which heat for building is provided by a highly focused, high intensity stream of electron striking work surface. Electron beam gun operates at high voltage 10 to 150 kilovolt typically to accelerate electrons. Beam currents are low, measured in milliampere power in EBM, not exceptional. Electron beam building high voltage cable, incandescent cathode, bias cup, primary anode, electron beam, focusing coil, deflection coil, weld bed, and vacuum chamber. In electron building process, vacuum chamber is required. Three vacuum level in electron beam building: high vacuum building, medium vacuum building, non-vacuum building. Building in same vacuum chamber as beam generation to produce a highest quality build. Building in separate chamber but partial vacuum reduces pump downtime. Welding done at or near atmospheric pressure with work position close to electron beam generator require vacuum divider to separate work from beam generator. Advantage and disadvantage of electron beam welding: high quality weld, deep and narrow profile, limited heat affected zone, low thermal distortion, no flux or shielding gases needed. Disadvantage: high equipment cost, precise joint operation and alignment required, vacuum chamber required, safety concern, EVM generate X-rays. Laser beam welding, fusion welding occur in which coalescence is achieved by energy of a highly concentrated coherent light beam focused on joint. Laser beam welding normally performed with shielding gases to prevent oxidation. Filler metal not usually added. High power density in small area. Laser beam welding often used for a small part. Comparison: laser beam this is the figure of laser beam welding process. Flash tube is used for flash tube and lasing material for generating laser beam. Laser full form is light amplification by stimulation, emission of radiation. No vacuum chamber required for laser beam welding. No X-ray emitted in laser beam welding. Laser beam can be focused and directed by optical lens and mirror. Laser beam welding not capable of the deep weld and high depth to bit ratio of maximum laser beam welding depth 19 mm, whereas EVW 50 mm. Deep weld and high depth to bit ratio. This is the comparison. Thermite welding, friction welding process in which fusion welding process heat for collisions is produced by superheated molten metal from the chemical reaction of thermite. What is the thermite? Thermite is a mixture of aluminum and iron oxide fine powder that produces an exothermic reaction when ignited. Also used for incendiary bombs. Pillar metal obtained from liquid metal process used for joining but has more in common with casting than building. This is the figure which is used for here thermite building is used for joining the two railway track. Thermite ignited, crucible tapped, superheated metal flows into mold, metal solidified to produce build joint. Joining of railroad rails, repair of crack in large steel casting and forging. Build surface is often smooth enough that no finishing is required. That's all about. Dear student, if you did not subscribe my channel, please subscribe so that you can get more useful video on the mechanical